Story time continued. So my phone fights back once in a while, and it just dropped. So, trying to pick up where I left off. So here was the job. Putting large automation cells into a large system that replaced people, like I said, about 60%. Most of the people that had to hold welding guns hours on end were exposed to some fumes and dust that is not very healthy for hours and lifetimes. Got a whole lot better, just exponentially better. So, yeah, there were trade-offs in this, and part of my rationalization was the jobs that are left here are safer. I went to the mat for my skilled trades to try to keep them structured in a way that supported my business. And so a lot of union give and take in there. Because we were bringing new technology in, we were replacing people. I was a contractor and luckily maintained good relationships, so the folks that were putting themselves out of work were very good people. So what did I do to counter that? As I said, I pushed on management to make sure that my union, my skilled trades positions, were staffed. The UAW got to bring people on and got to reopen some of their skilled trades training programs, in small part because of the pushback I gave with letters and proposals and propositions and conversations about what I had to have to maintain a new world of electronics. So what I brought with me was electronics that needed an oscilloscope to look at, an oscilloscope to understand. It required tuning in sequences and the following of procedures that an electrician was familiar with the procedures but not using an oscilloscope necessarily. So, introduction to oscilloscopes. You have a battery in that vehicle that is basically a forklift battery. These are a few thousand amp 48 volt industrial batteries. Some newer technologies, sealed lead acid cells, which used a different type of cell membrane than normal lead acid batteries, and industrially didn't release the hydrogen and the acids that at the rate that normal lead acid batteries do. So over the years I went through the battery technologies and the electric vehicle technologies to move materials around industrial areas. So I was with this corporation putting in these automation systems. For this company, I was also doing design bids for 3 other systems. And my part of the architecture was the computer control systems. So these were usually redundant high availability systems, and so my designs were to allow for that high availability functionality and allow for system changes. So you had to have a development environment to be able to test any changes you're going to make before you could put them in production, because that's how you do it right. So remember, putting things in production here means you're reprogramming a robot. You're reprogramming a button. It does something different, and you've got a 20-ton vehicle running around that's following a wire in the floor, and it better not do something wrong or you can get hurt. A robot better not do something wrong or you can get hurt. Equipment gets destroyed, production's down, you lose money, you've got to clean up the mess. So you think, you walk in the door thinking. So I worked for this conveyor company, and we were kind of wrapping up there. And General Motors all of a sudden realized they didn't have the engineering staff in-house to be able to do much with these systems. So through an act of the president of General Motors, he hired roughly 24 engineers in our field to be able to carry GM forward and keep these things running, because they were very complicated systems. They used Z8085s, 8086s, A to D converters for tracking analog wires in the floor. They had optical communications devices that talked basically RS-232 communications. They had transmitters, antennas that transmitted to wires and loops in the floor. They read signals from wires and loops in the floor. If they were at a station where I needed to, I could send them a new program to go someplace different. If they weren't near someplace I could talk to them directly, I could pulse wires in the floor to give them some signals to go somewhere. They could pulse the floor back and tell me where they were. I had charging stations. This was a pure demand charging, so my vehicle batteries got charged in basically a 37-second window or a 42-second window, depending upon what type of automation cell it was. So I had 42 seconds every few minutes to get enough of a charge in a battery to run all day and be ready for the next day. So in my electronics, I monitored this stuff. In my systems, I built programs to tell people the batteries were getting low and that they have to go get that vehicle out of the way and on a charger before it dies. Because if it dies, now it takes another forklift and 6 people and a lot of time to get it out of the way so you can continue production at 60 vehicles an hour, vehicle a minute. Pick a price of a vehicle, that's what you're building, that's what you need for the day, is that many an hour. So you do what you need to try and make that happen safely. So yes, when I came in, our systems, our specific design and asynchronous manufacturing was being tried out in 4 General Motors plants with one specific vendor. Canada and a few other plants had another vendor supplying the same type of vehicle through a different supplier. So the technology was marginally different. Same thing, just different vendor names on there. You had to be able to read a schematic to be able to see what the differences were between some of these things. But the principles, the operating principles were the same. So over time, I did consulting with a lot of other plants trying to get improvements to these systems. How do we make them better? Another element is, can we do this? If we want to make this vehicle go from A to C instead of A to B, how can we do this? What do we have to change? And I could affect those changes on the fly depending upon manufacturing needs. And I could do it easily for 4 assembly plants and a little bit harder for dozens more. So this is a kind of travel that you get. These are the things that you're doing as an engineer, coming in and out of facilities, supporting programs and projects over time. So it was very unique at the time I was hired in, and the reasons that the people that were hired in were hired, it was a business decision. So there I was in the middle of General Motors, building automobiles and trucks and seeing the new car lines coming in and being designed, helping the build process run faster and smoother and all those great things. And that's what engineers do and still do. What has changed, huge, and this was part of the transition that I saw. Working in their engineering systems or engineering shops, these are huge buildings that used to have thousands of draftsmen drawing with pencil and paper and pen and ink and doing the designs. And part of what we brought in was AutoCAD, something most people are familiar with. But these were the industrial versions of AutoCAD. This was the other side. AutoCAD's birth was back into systems, okay, let's say military systems, because the sciences came from those that DARPA funding of things unknown. So there's the path. There's some of the evolution of how the technology got here. So my peers in that business had worked for NASA contractors, did the real-time control systems for the space shuttle simulators and maintained those systems. So these were engineers that did the control systems for hydraulics and electrical controls, and right down to the flashing lights on the boards inside the school buses, you know. Another individual worked for a spy agency doing communications studies, let's say, but it was on the software signal analytics side. It would have created the information that some analyst would have gone to analyze to see if it was something that should have been analyzed. These were folks that had worked on photography systems and gone into camera systems. So we did body imaging with lasers for dimensional checks and controls. So these systems, this is 1980s, you know, the big home computers were coming out. Every one of those, I had seen the transition of the technology that they were based on, where that came from. Not the software that they were writing or bragging about or becoming heroes over. The business around all that technology, it was the technology that came from our national research and the search for a safe world. The nuclear funding, nuclear research at the atomic level, the tools that came out were developed in that realm. The spectrometers, the chromatography, the lab instruments, the ability to detect things at a molecular and an atomic level and begin to discern what those things do when put together. So now I got 2 videos to try to put together, broken apart. We'll see what happens. But hey, if you lasted this long, youth tip of the day: global information systems architecture. This is defining standards for information that everybody can use and understand. This is helping create a standard, specific example, a standard of a format for your location, not yours, the we's location, right? Whatever that location is, there are a number of ways to type out the geographic location. You can use a street address, you can use a GIS designation, which would be latitude and longitude and altitude. But latitude and longitude should give you altitude. So do you need to put altitude in there? Yes, no, maybe. So this is constructing that GIS, global round earth information, that somebody on the other side of the planet can compare to his information. So if there is a solar storm and both sides of the planet see it, we know more about it today than we did yesterday. This is engineering. This is the body of knowledge that we have built over time that is not absolute. It can't be. It realizes in itself it's not absolute, because we are finite beings. We have an end. The universe the planet has an end. The universe has an end. And whether it'll be happy or not, the universe doesn't seem to mind. So, all right. GIS information structures. This is things like metadata definitions. What do you need to know about information to make it useful? Again, the globe spins. We fucking know this. You can't touch these jobs. You can't think about these jobs unless you have a perspective of, not a perspective, unless you understand the planet is old, the planet spins, the planet uses the same time on the planet. It doesn't care about our time, and yet it does. Mother Nature has seen us. She has spotted us, and she's reacting to us in her very own, very subtle way. She has taken notes as Mother Nature takes them, and she's going to do corrections to get back to where she thinks she needs to be. She is a beautiful man. She is a gorgeous woman. She is our future we ride on, and hey, for posterity. Cats in the cradle.